So today we're going to look at the basic logarithm laws or log laws. I'm going to keep this video fairly simple. I'm not going to do proofs of these laws. I'm going to try and work on giving you some basic tips on really how to memorize them really, because most people struggle with log laws when they first see them. I certainly remember when I first saw them, it was quite difficult to get my head around. That's really what the video is going to work on. So let's start with the main thing that you need to know. This is by far and away the most important, and it's the bit that most people struggle to get their head around. It's really looking at what a logarithm is. The notation I'm going to use here, to be honest, I'm going to kind of make the letters up as I'm going along, really. I might put some numbers in as well, and I'm really just kind of making this up because I think one of the problems is that people see formulas in books with certain letters in them, and then they need to follow those letters, and when those letters are missing, it all falls apart. A good example of that would be something like Pythagoras, okay? Most people learn Pythagoras as a squared plus b squared equals c squared, but really the important part of that formula is to know that c is the hypotenuse and it's the longest side. You could call it h for hypotenuse. The c is unimportant. If you've got this kind of setup, this is really saying, well, what is this left-hand side? What does it mean? We'll call it P, but what does it mean? Okay, and really it would be this. Okay, these two things are kind of different versions of the same thing. Okay, one's the log form, one's the exponential form. So it's really looking at this and saying, well, what power do we need to raise x by to get to the number 4? Okay, I put a number 4 in, I could have just put another letter in. Okay, so it's rewriting these things that is the most important thing with logs. Let me give you a quick tip on how to do it. If you're trying to go from the log version to the exponential version, start on the left-hand side. So when you look at the x and the 4 and the p, the x comes first. It's kind of to the left of the other two. So you would start with the x, okay, but then you kind of, you can see this a bit like a circle really. If you go kind of anti-clockwise round to the p, and you put that in next, okay, and then you follow that circle round, and then you arrive at the 4, and you write them in that order. Okay, it's not a very technical explanation. It's a way of you just being able to look at it and instantly write this down every time. I would say work on this until you get it right every time, and don't really bother doing any other logs questions until you do. Because if you can't do this bit, you're not really going to be able to follow any other logs questions, okay? So that's my tip for doing it. Like I say, that's not a technical explanation. There's no maths in there. That is just really what you need to learn, okay? So in terms of looking at it a little bit more technically and saying, well, you know, why do we need to do this, and how does it help us in maths? What kind of questions would we be looking at? Well, let's look at something that we probably know the answer to. So let's look at an exponential form of something, okay? And if you look at this, most people, that would probably jump out at them that x is equal to 2, because we know that 5 squared is equal to 25. 25 is a square number. We just kind of know it, okay? But let's write it in logarithmic form, okay? So it's log, and the 5 is the base. The 5 is the thing that goes down here. It's the base, okay? And then the thing that we're trying to find is x. We're saying, well, what is x? So it's kind of like, well, you certainly need equals x all on its own. And then really, there's only one place to put the 25, and it's here. Now, if you put this into your calculator, then you're going to get the answer of 2, because because of what we said earlier, we know that 5 squared is 2, so the missing value for x there is a 2. So your calculator will calculate that for you. So you might look at that and think, well, what's the point of that? I know the answer's 2. Well, the thing is we can use this exact same technique for solving something that we don't know the answer to. So if I just change that number on the right just slightly, it should be fairly obvious that the answer here is going to be slightly bigger than 2. We would need a power that will be slightly bigger than 2 to be able to get to 26. Okay, so we wouldn't know the answer to that. We wouldn't really be able to calculate that, but we would be able to do exactly the same technique and write log to the base 5 of 26 is equal to what number, and it's this left-hand side that you would put into your calculator. this really shows you the sort of questions that you would be able to answer now using logarithms. So the first log rule that we're going to learn. Okay, now again, we could use all sorts of different letters here. I don't want to confuse things, so I'm just going to use A and B. Okay, but this is our first actual log kind of rule or law that we need to kind of learn. Okay, so what it's saying is that the logarithm of two numbers or two things times together is the same as adding those two logarithms. Now, the best way to, again, kind of remember this law without getting too complicated and doing proofs is that it's based on your indices rules. Okay, so your indices rules that you're probably a lot more familiar with would be something like x to the power of, let's just use A and B again, but if you were timesing x to the power of two different numbers, then the law is that we add those two numbers together. So there's a link between addition and multiplication when you're doing indices, and you can see from the log law that there's a link between multiplication and addition. So you shouldn't be too surprised to see what the next law is really. There's going to now be a link between division and subtraction. Again, exactly similar to your indices laws. Okay, so again, I'll just do an example. So if you had x to the power of A and you were dividing by x to the power of some other number, okay, then the rule that you use is subtraction. So the next law I'm going to write in a slightly different way, at least to start with. But just bear with me a second. I'm going to put two a's in there, which we wouldn't normally write that like that. We would normally write a squared, and I will write it as a squared in a minute. But I just wanted to write it like this to show you that, well, we're just applying the same law that we learned just a minute ago. Okay, if two numbers or letters are times together, then we add the logarithms. Another way of writing this, though, is to, if you've got log a plus log a, well, that's just the same as 2 log a. Okay, if I had three of them, it would be 3 log a. Okay, so when we look at this, if we now rewrite the left-hand side and say, well, look, a better way to write AA is a squared, and then we get this law here. Okay, and it looks like the 2, the power 2, has kind of been brought down to the front, and that's really how you want to remember this. So let's do it in a more general way. Let's say we've got log x to the power of n. Then we can bring the n down to the front. And of course, all of these laws work both ways. Sometimes we bring the n down to the front, sometimes we would take this n back up here as a power. Depends on the question. Okay, so this is an important law, but it really just comes from the multiplication law. That if you see any other laws in your book, or your teacher gives you them, or you see it in other videos, they're not really new laws. I will just do one example of that. So sometimes I see this law written out either in books or students look at it and they get confused with it. But you see this and it looks like, oh, it's a new law. It isn't at all. And I would encourage you not to learn this law at all. What I would encourage you to do, if I just get rid of this right-hand side, if you were looking at this and you were trying to consider what this is, you would just use your indices rules, okay? You would look at 1 over a, and you would remember that your negative powers create fractions, so it's this, and then you can apply the power law, and you can bring this minus 1 down to the front, so that would give us minus log a. It's not a new law at all, it's just a use of the power law, and it's about knowing your powers and indices well. So we'll have a quick look at this exam question. Okay, this is really fairly simple. Although it's 3 marks, it is very simple, and it is all about using the first rule that we looked at and just being able to write this in logarithmic form. So it would be log. The base is the number, the main number. Okay, so that's 0.8. Okay, and then I would sometimes I just leave a gap there and say, right, I'm trying to find x, so I put that in, and then it kind of frees me up to put this 0.05 in here. Now, this looks really weird, and it's really quite tricky to try and think about what the answer would be, but you don't really need to. As long as you can write it in the right form, you would just pop this into your calculator, and it will give you the answer. So this question is a little bit more interesting and actually gets you using some of your log rules. My tip for these is when you look at an equation like this and you've got lots of logarithms and you're thinking about a few of your laws, I would always kind of look at this 2 here and think that's not very useful. I don't really want any numbers in front of the logarithms. To be able to apply your log laws, you can't have numbers at the front. Okay, so what we can do here is we can just leave the left-hand side as it is. Okay, and we take that 2 up as a power, so it's going to become 6 squared, and everything else I've just copied down. Then again you just copy the left hand side, and now you have a logarithm subtract another logarithm. So we know from our log laws that that can be written as a division. And then you just go and actually calculate 6 squared divided by 3. So 6 squared is 36, divided by 3 is 12. And when you get to here, it kind of looks a bit as if I'm cheating a little bit, but you can kind of just cancel out this log A and log A. I mean, it's really just saying, well, what number is this? Oh, it's 12. It's not an equation that you're going to kind of rearrange and get x on its own as such. That comes a little bit later on. You've really just got a left-hand side is identical to the right-hand side, so x must be 12. So again, this is a fairly basic question, but the reason I've picked this one is more to have a look at this logarithm here. It's log to the base a of a bracket. A really important thing to note here is that just under no circumstances should you ever think about expanding a bracket. So this is not equal to expanding that like that and separating it like this. Okay, it's not like you're multiplying the bracket out like this. This doesn't work. It should be obvious because if you look at what we've written here, or what I've written here, we've already got a rule for this. There's a division law for this. So it should be fairly obvious that you can't expand a bracket like that, but it is one of the common mistakes. Common mistakes come about when people don't know what to do, so they kind of just try something. So they'll look at this and they'll expand it. What I want you to do is look at this as just as if this bracket was just a single entity. I'll just call it B for bracket. Okay, and if you see that, you would look at this and you would times the 3 and the b together. Okay, so we'll just copy the left-hand side down. Okay, so this is going to be a single logarithm. And that's really what you do in a lot of these questions. You have lots of logarithms and you create single logarithms using your log laws. Okay, so this is going to be 3 times the bracket. Okay, well, and in fact, let's just put that in there like that. Okay, just to illustrate what I'm doing. But of course the bracket is 2n minus 1. So this is log to the base a of, well, it's going to be 6n minus 3. Okay, so again, similar to the last question, when you've got a log on both sides and they're the same base, then you can kind of effectively get rid of the 2 logs. N must be the same as 6n minus 3. And once we get to there, it's no longer a logs question. Okay, the rest of the question, it's just purely a piece of linear algebra. If we collect the n's on one side and the numbers on the other side, we should get n equals 3/5. Okay, so if I just split that here, it's a logs question and then it's a linear algebra question. Okay, so final question to have a look at. We haven't got logs on both sides this time. We've got this equal to 1. But that shouldn't be the focus of your attention to start with. You should be looking at this and thinking, well, what log laws can I apply? And again, this 2 at the front needs to be the first thing that jumps out of you. And we need to take this up here because we can't apply other log laws to this log with that 2 at the front. Okay, so I'm going to kind of just save myself a little bit of writing. Okay, this 2 is going to disappear and it's going to go up here and be squared. Now when you look at this, it is a log take away another log. So we use the division rule. And the division rule can be written wrong. I'll show you the wrong way to write it in a minute. Let's do the correct way first. So it's this bit, which is of course now squared, over the other bracket. As simple as that. Okay? And that's all equal to 1. So what we've done is we've created a single logarithm. The common mistake here is to write this as log to the base 3 of the x minus 5 squared, and then people do a division, but they write the word log again. So when you look at it this way, I've written 2 logarithms, okay, and that's not the purpose of what we're trying to do. Log laws combine 2 logs into a single log, so this would be incorrect. Very common mistake. Okay, so next step here, well, when you've got a single logarithm equal to a number, this is where you can use the main rule that we did at the beginning. And again, probably a good way to see this question is that it's log to the base 3 of a bracket equal to 1. Okay, how would we rewrite that? Well, we would start with the base, the 3. We would go round to here, okay, and put the 1 in, okay, and that's equal to b. Okay, so obviously 3 to the power of 1. The bracket is equal to 3 to the power of 1. So you just got to get used to kind of, instead of writing b, is just to copy this big bracket out. Okay, you can write the b if you want. There's nothing wrong with this technique as long as you put this back in at some point. So this big bracket is equal to 3. Now again, I just want to stop there and sort of say, right, the logarithms part of the question is over. It's finished. You should recognise that this is going to be quadratic. So let me know if that's been useful in the comments below. Feel free to email me with any slightly different questions that you've got on this, or any suggestions for further videos, either on logs or any other topic. But if you wanted sort of more detailed or more difficult logs questions in a separate video, yeah, just mention it in the comments and I'll see what I can do. Okay, take care.